want you to be in here for the first part.
Oh, okay. Perfect.
But careful with that.
You want me to just go straight out?
No, because you should be in here for the other parts we need to go over first.
Gotcha.
Right when we start going over, you don't have time.
Was there any papers?
Or not new ones.
Not new ones? Okay.
Oh shit.
And which ones do I have to turn
Oh.
on again? Like 88 and 89?
It was 3.2.
Worksheet number 3 and then...
No, not this one. And then this one.
Yes, I got a test Monday.
Why are you in translation?
Friday, right? Yeah. Yeah.
You don't know that it's Friday? Two waffles and one.
Yeah, sure. Oh, dang. 1 point.
Yeah, I'm going right now. Two waffles and
Dang it. So close.
you need a white monster. Oh, buddy, this is crazy.
Oh, you don't know which ones to go.
It's the white monster. It's the white monster.
Yeah, my brain is blanked on C. On 6C.
I'm not sure.
You can do the
Wow, Brandon. Wow. I'm just kidding, sorry, Brandon.
25 out of 20?
That would be like 25 out of 26.
Oh.
Sorry, I don't know where you're going.
Dang it, I'm just like getting like 1 point off from all these quizzes.
I mean, it's a good quiz.
I know, it's the 1 point.
If you made 100 on all of them, it was too easy, and then you would try it.
Yeah. Guess you're right.
You only lose 1 point. You still will be fine. Are the bells turned off again?
No, there are.
I can hear it.
I made them stop actually. Telekinetic powers.
Wait, wouldn't it be 1 over smiley face?
It's just silly. It's not real.
I mean, you almost got it.
You let it go. You're welcome to, you let it go in this one. That's not the point I got up. Although I should have. I'm saying, well, maybe you should have taken off.
Which one?
That's not the point I was talking about.
I'll look it up. I need that on it.
Actually, it's been good. I'm actually trying.
Alright, so first thing is, yesterday I posted in Google Classroom about us being kicked out of here next Wednesday. And originally when I put that in Google Classroom, I said Monday because that's what was sent to me, but that was not correct. I'm actually getting kicked out of here Tuesday and Wednesday for some testing. Of course, Tuesday doesn't affect y'all, but Wednesday does. So, if you come very far up to this room, you might want to make an alarm in your phone to remind yourself not to come all the way up here on Wednesday, and instead go straight to room 1105, which is Mr. Williams' room. But if you forget, it is on the agenda here, and I put it in Google Classroom, so you can pull it up on Wednesday, I guess, if you need to. Also, since we are splitting the test into two 50-point tests instead of one 100-point test, that means it is time to review for the test. So last class I saw you, the test review that you got like a week prior, I said the question types on the test review that you would be responsible for were questions 1 through 9 and number 11. So none of the rest of it, but those questions. So y'all need to get that out and see if there's anything you needed help on from that so that I can help you. Then I'll give you a couple minutes to look at your 1.9 quiz, which is where we did inverse functions. Answer any questions you have there. Give you a minute or two to look over your 3.1 quiz, which is over exponential functions. Let you ask questions there. And then give you a couple minutes to look over your 3.2 quiz, which was the start of logarithmic functions, and see what you need to ask on that one. So just like last semester, we haven't had many traditional tests this semester, but I think the best way to prepare for your test is to learn from your mistakes on the quizzes. Anything on the quiz is likely to be on the test, and then also test review. Anything on the test review is likely to be on the test as well. So that will be on Monday.
Well, it probably won't be doing that.
I used 1 point on every single one of my quizzes.
Okay, you'll just need to
Tuesday,
come in
prime time.
Tuesday prime time. You should probably go ahead and sign up though.
Okay.
Yeah,
You said the test will be on Monday.
correct. Today is the test review. Okay, so from your test review, questions 1 through 9 or question 11, which of those did you have trouble with? Or just would benefit from discussing it again? Yep.
Could you do the part of question 1?
Question 1, part H.
Which are we going over?
This is from the test review. Test review, then the quizzes in the order that we took them. Okay, H was asking you to try to sketch a graph of this and to make a table with some points. Now, to have a general sketch of what this looks like should not take you too long because you've got 2 to the x. All exponential growth looks like this. And then it gets shifted left 1 and down 1. So imagine this left 1, down 1. That's what our final answer should look like. Something like this, roughly. But we need it to be a little bit more accurate than that. So if we start plugging in some of these numbers up here, like if I plug in 0, you would get 2 minus 1, which would be 1. So there's a point 0, 1. If you plugged in 1, you would get 4 minus 1, which would be 3. If you plugged in 2, you would get 8 minus 1, which would be 7. If you plugged in negative 1, you would get 1 minus 1, which would be 0. And if you plugged in negative 2, this ends up being a half minus 1, which would be negative a half. Okay, and obviously you can do more points, but if those are the ones we put on there, if we did that on the test, you'd have to plug in more points. So again, I knew kind of what the shape was going to be just by knowing what 2 to the x looks like, knowing that it was going to be shifted left 1 and down 1. But after I plug in these values, solve for y, plot them, then I've got a very pretty accurate sketch. Okay, somebody else? Anything from the test review? I will point out that my other classes have noticed question 9 on the test review is about change of base. And that did not end up on your 3.1 quiz, but if it's on the test review, there's a chance it would be on your test. So make sure that you remember that or look at it in your notes if need be. Okay, if I'm moving on too quickly there'll still be plenty of time. So next up, this when you guys came in today, you had your 1.9 quiz on your desk. So you need to look over what you missed. Obviously, some of it could be careless mistakes that you don't need to ask about. But if that's not the case, if you don't remember, or if you have no idea how to do a question, this is your chance to ask. So 1.9 was about what it means to be one-to-one, proving functions or inverses with composition, knowing how to take points on a function and find points on an inverse, how to take a function and find its inverse, and that was pretty much the majority of it. Now I will also add before you look through this that of the 3 sections on your 50-point test next class, 1.9 is certainly the least important. There'll still be some test questions on there. You still need to make sure that you're good and understand what you should from the quiz, but your test should be more heavily weighted to 3.1 and 3.2. Brian, Ben, Luke, Thompson. Okay, so for the 1.9 quiz, you will have to tell me which form you had. I think in here we used forms A and B, but may not match up perfectly from one form to the next, so I need to know. Yep.
Form A, 3A.
Okay, so the one that says the function that is not one-to-one.
Yes.
Okay, so what it means to be one-to-one is it has to pass the vertical line test and the horizontal line test. But this question says it's a function that's not one-to-one. So to be a function, he needs to pass the vertical line test. This needs to be true. But to not be one-to-one, he has to fail the horizontal line test. So pretty much anything that you can draw that will pass the vertical line test to make sure that it's really a function, but not pass the horizontal line test so that it's not one-to-one. Something like x squared is easy, but there's lots of correct answers. Yeah, Diego?
Form A, number 5.
Okay, so this one gave us a function and asked for his inverse and what would be the domain of his inverse. So to find an inverse, that's where you're swapping input with output, so switch x and y, and then solve for your new y, like so. And this is not the same as this y, so this is where we used a different notation. So that's what you needed for the inverse. I think some of the issue is like right here, some of you guys are like trying to say the square root of x plus the square root of 4 and change that to 2, and you can't do that. If you've got terms here, you can't just take the square root of these separately. I think we've talked about that a few times recently. You okay with that part? Okay. And then the domain, you could do one of two ways. Either here's the inverse function, you could graph this. So square root of x looks like this. Shift it left 4, looks like this. And so then you could see the domain is -4 to infinity. Or the other option I gave to you so that you had a backup here, if the function looks like this, x squared shifted down 4, you could think about his domain is all real numbers, which makes that the range of the inverse function, and the range of the function, what's the range of this? -4 to what?
Or infinity.
Infinity. The range of the function becomes the domain of the inverse function. The possible y values become the possible x values. So you had two ways to go about the second part. Okay. Anybody else for 1.9? Yes, sir. KJ.
Will you do 3A? Or, yeah,
Three.
B.
Form B, number 3A.
Just number 3, I said 3A.
Oh. All right, well, that's going to be pretty much the same thing. That's the same type of question. So actually, let's just make some adjustments here. The difference between this one and your form is that this was not a 4, but a 9. So when we start solving this, this becomes 9. Add this over, 9. Take the square root of both sides, 9. So there is one part of your answer. You okay with that? Switch x and y, solve for y, rename your y as inverse. And then for the domain, if you wanted to graph this, you could still start off with square root of x. Square root of x is considered a parent function that you really should have memorized. And then if you shift it left 9, it's going to look like that. But his domain is going to be negative 9 to infinity. Or you could graph this guy, pretend like this is negative 9. His range would be negative 9 to infinity, and the range of the function becomes the domain of the inverse. So you got two ways to come up with that. Exactly the same as the other form, but instead of a 4, it was a 9. But main thing is, don't try to do this. Don't try to say square root of x plus square root of 9 and simplify the square root of 9. You can't do that. Guys, did y'all get lost? You got a pass or what?
It's school business. We came from the computer science.
Okay, you're not marked to school business yet, so you'll have to make sure they update that. I can't change it to school business.
Okay, yeah, otherwise.
I'm not sure. Just whoever it was, to make sure that they know so they can get it fixed. Okay, if I'm moving on too quickly from that one, you will have a chance to ask more, but let's move on to 3.1. So 3.1 was exponential functions. Trying to figure out the difference, if it's going to be exponential growth or decay from the function, graphing exponential function and answering characteristics about it, describing transformations from the function, picking out graphs from transformations, horizontal asymptotes, compound interest formulas, and half-life formula. So go ahead and look over your 3.1 quiz. And you will need to tell me which form you had, if you have questions. Yeah, Diego.
Form B, number 17.
3.1, Form B, number 17. Actually, I don't know if I have one. Which of the following formulas would you use to find the amount of interest if you invested $5,000? So that would be your starting amount, principal, at 6%. So that would be rate, but we don't enter it in as a percent, we enter it in as a decimal. For 8 years, so T would be 8, and is compounded quarterly. So what does that mean N is going to be?
4.
Okay, and if it's compounded continuously, like question 18, that's when you use the PERT formula. If it's not that, then it's the other formula. And we do insist that you memorize this one that you should need for the ACT as well. So the answer should be the one with that stuff plugged in. Starting amount in place of P, the rate in place of R, but as a decimal, N, I know when you hear quarter, you think 0.25 because you're thinking money, but N is not, N is how many times a year it gets compounded. So if it's compounded quarterly, it gets compounded 4 times a year. And then N and T. So that's why that was the answer.
Oh, I swapped what was the exponent. So I chose B instead.
I'm looking at it, it looks like B to me. B as in boy.
Circled it as D.
Oh, I'm sorry. Yeah, D. What's the difference?
They're just flipped.
No, B has an 8 right here.
Yeah. Oh, I didn't see that. My bad.
That's the difference. Yeah. Simply 4 times 8 and 8 times 4 is the same thing, so it doesn't matter that those two are switched. It mattered that that was an 8. Yes, you're right. D is in dog. Sorry, that's the one that he missed too. So I was looking at his answer, not the correct answer. Now, I will add that our test is no calculator. So if we put these compound interest formulas on there, it'll probably be multiple choice like this was. So we obviously don't expect you to be able to do that in your head. Okay, anybody who has not asked a question yet today, have one from 3.1, give you a chance before other people. Okay, anybody that has asked a question have more from 3.1? AJ?
Will you do 16 on Form B?
B16. Okay, this is one of the horizontal asymptote questions. So these are the question types where I said, I think it's in your best interest to memorize 3 things. N to 0 goes to, N to infinity goes to, and N to negative infinity goes to
0.
0. That one's the one that's a little less intuitive. The others kind of make sense if you know that exponent property. But for 16, we wanted to know what happens at the right side of the graph, what is y approach, and the left side of the graph. So one time you need to plug in positive infinity. I'll do that in red. And then you got to figure out what all of this mess goes to. And usually the biggest mistake that y'all make is trying to do too much at once. So if I was you, I would just do this first. Leave the rest of it alone. So 0.4 times a number that just keeps getting bigger, so that goes to infinity. Then if you have these memorized and ready to apply, e to infinity is this one. This just goes to infinity. If you add 2 to a number that keeps growing, it's going to keep growing. And then what happens in a fraction if your denominator is stuck still, but your denominator keeps, or your numerator is stuck still, but your denominator keeps growing? Right, it gets closer and closer to 0. And then you needed to plug in negative infinity. Sometimes these have the same answer, sometimes they don't. You actually have to work it out. But my advice is still the same. Do as little as possible at the first couple steps especially. Now, 0.4 times a number that keeps growing is still going to keep growing, just like it did up here. But this was a positive times a positive, which gives you positive. This is a positive times a negative, so it's negative. And that's a big deal because e to the infinity goes to infinity. E to the negative infinity goes to what?
0.
And how do you know it goes to 0? Right, it's this third one. If you're ready to apply that, then that doesn't take you near as long to know the denominator goes to 2, so the whole fraction goes to 5. But right here, that was pretty much the only difference. This to this, and then these two. The rest of the question was the same. But sometimes those have the same answer. The other one should have had the same answer. This one had different answers. So don't assume they should be the same. Don't assume they should be different. Okay, Luke, you had one. Were you raising your hand a minute ago?
I was just about to, but
Okay.
it was just over that side.
Again, I guess there's like no rule that says you have to memorize this. I just really think it makes it easier if y'all know those three, especially this one. So you can make that substitution quickly. Okay. All right. Last call, others in 3.1. Okay. All right, those of you that are making up the 3-2, you'll need to put your phone up there on the wall, please. And then y'all can finish up in the hallway. Everybody else, go ahead and start looking over your 3-2 quiz. So 3.2 definitely has the most amount of information, which I think makes it probably the hardest of the three quizzes. But the 30-second recap, switching from logarithmic form to exponential form, in case you needed that to solve an equation. Question 2 was all about applying some of the properties. Question 3 was about graphing a logarithmic graph and naming some of the characteristics. So was 4. Question 5 was picking out some transformations from a graph. Question 9 was naming some transformations from a function. Number 8 was evaluating some logarithms. Number 7 was about knowing exponential functions and logarithmic functions are inverses of each other and that relationship. And then question 6 was a couple solving equation type that we have asked you to look at. So as you start to find questions from that, tell me which ones. Yeah.
Form A, question 6C.
16. It might take me a minute to find one, but here we go. Nope, that's 3.1. Okay, I'm glad you asked this one because fortunately this one doesn't take much correction if you missed it, but this one might be the most important if you were doing calculus or college algebra next year. So I mentioned this a few times, but eventually when we get to section 3.4, that whole section will be about solving equations and we'll be doing more complicated ones. But what y'all need to be doing at this point is just 3 different things. This is one of them for solving equations. And it's the type where you might have log base 5 over here and log base 5 over here, so that part's already balanced. And then you just need to make sure that you're taking the log of the same thing, so you make sure that the insides are balanced. The reason why I was saying I'm glad that you asked this one is because this needs to be a red flag to you if you got stuck here, you tried to solve this in a creative way. If you're trying to do something other than putting it all on one side set equal to 0, that's not how quadratics work. You have to put it all on one side set equal to 0. Unless it's just something like super basic like this, you have to put it all on one side set equal to 0. If you don't, and you're trying to figure out when this equals this and you're getting creative, that never works out. Secondly, once you get down to here, what's the only way that always solves the quadratic? Quadratic formula. I'm assuming you want to avoid that and instead do what? Okay? If you are going to factor, you better factor it correctly. If you have to slow down and do that product sum method that I showed you earlier this year, if you need to do a method from something that your Algebra 2 teacher taught you, that's fine. But factoring is the most important thing y'all should have gotten out of Algebra 2. You're going to factor a lot in calculus, and you're going to factor even more in college algebra.
And that's not something that, you know, you're not going to take time out of class to relearn factoring at that point. So my guess would be maybe you forgot this 2. Yeah, x times x doesn't give you 2x squared though. One of them has to be a 2. So set this equal to 0 and solve, set this equal to 0 and solve. Really the only thing about this question that has to do with logarithms, other than there was a log here at the beginning, is at the end of the question. One or both of these may not actually be correct answers. Not that I factored wrong, not that I solved this wrong, not that I didn't deal with the quadratic correctly, not that my first step is down the wrong path. It's just that logarithmic equations like this can often have extraneous solutions. So if you take this answer and plug it into the original problem, this is a little bit harder to evaluate, but this comes out to be log base 5 of 3 over 2, and this ends up being log base 5 of 3 over 2. So first off, it's good for you to see that the left and right are equal, because then that confirms that this is right. And then when you try to plug in -1 into the original problem, you get log base 5 of -1 equals log base 5 of -1. So the left and the right equal, which sounds good, but this is what we call extraneous. Why is it extraneous?
You can't have the logarithm of negative.
And you also can't take the log of 0, but how come? This is saying, like, if we know how to read logarithms now. This is saying 5 to what power gives you -1? There's no power of 5 that gives you -1. If you think of what 5 to the x looks like, he never equals 0 and he never equals a negative number. So even though all of this work is great, this was an extraneous answer and you should not include it. Only that one. You have to check your answers with logarithms, even if you're confident in what you were doing before then.
I think I just forgot how to factor it.
You okay? You can step out if you need to, or go to the bathroom.
Yeah, no good.
I forgot
Now, one thing that you did have, I think this is a harder question just because it's a little bit longer, but it was only 1 point on the quiz, so it wasn't very punishing. But of course, if we put one like this on the test, it might be 2, 3, 4, 5 points. So on one hand, you could get some partial credit, I guess, but also you could maybe miss more points than you would have on the quiz. So.
Right.
But also, when you said that you didn't factor it correctly, remember you should always check your factoring. Multiply this together and make sure it goes to that. If it doesn't FOIL to give you that step before it, then it's not factored correctly, and you got to try something else.
I got confused on the 2 in front. I forgot to do 2x times with x.
Yep. Okay, is anybody else going to ask about this one before I take it away? I think the other form had an answer of 5, but it was the same process. And I will add that I don't know that I did anything differently, but you guys did better, far better than most years about students checking the extraneous solutions. Students who did this correctly and factored it correctly did a great job of checking to make sure that they shouldn't include both answers. Usually that would be one of the most common missteps, and I would say more of the mistakes were up here, remembering how to solve a quadratic and the factoring of the quadratic. Okay, what else from 3-2? Yeah.
I see exactly what I did wrong on number 7, form B.
Okay. 7B.
I don't remember. I'm not sure I don't remember why it's the way it is the correct answer.
Okay, so what I was saying a second ago that I didn't elaborate on, but when we solve equations, there's a lot of ways to solve logarithmic equations. In fact, somebody came in during lunch today to ask a chemistry question, and I told them I didn't know anything about chemistry, but it was actually a logarithm and a logarithm property that they were doing in AP chemistry. Is anybody in AP chemistry? Okay, so what I'm going to say at the end of this question is what helped that student realize what that teacher was doing. And that is, so one of the three ways we expect you to solve right now is questions like this. Seeing that log base 5 equals log base 5, set the insides equal to each other. That's one. Question B shows you the other two things that you're on the hook for currently. One is, sometimes you just need to evaluate this using properties. So in part A, that's all you had to do. What does this equal?
Number 7.
This is number, oh, I'm sorry.
Sorry.
That's fine. I'm going to finish this one. I thought this was the one you're asking for. This is number 6B. When you said B, I was thinking of the question, not the form. Yes, you can sign up and take pass. Okay, this comes out to be what? So that's one thing you need. That's the second of the three. And the third of the three, the one that y'all don't think about often enough, but this is why we do it, not just because it works, but because of this. Logarithmic form switched into exponential form is often a good way to solve those. Okay, your actual question, number 7, is it 5 to the x?
Yeah.
Its inverse is log base 5 of x. You pretty much just have to memorize that. If it was 3 to the x, your answer should be log base 3 to the x.
There's just some ones like at the start it said log r p equals p would be like
Number 7?
no, I was just no, I get it now. I thought.
Like in theory, if you're thinking of it as exponential, like in theory you can switch x and y and solve for y, but we just haven't solved logarithmic equations that are this difficult yet. That's why that's not a good approach. You really just should memorize that relationship.
Okay. It's just a relationship with the
Yeah, it's like when we talked about graphing logarithmic graphs, I always started with an exponential so that I could just switch x and y and get some points on the logarithmic. But if I was trying to graph log base 3 of x, I would start off with 3 to the x because that's his inverse. If I want to graph log base 8 to the x, I would start with 8 to the x because that's his inverse.
yeah, I see what I did. Those.
Okay, others from 3.2.
Can you do number 4 on Form B?
Form B number 4. To me, this is definitely one of the trickier questions. This was really the reason we did that worksheet 3. That was pretty short, but we backtracked. We started with question 3, then 2, then 1, and question 1 was like this one. So to work something like this, I think one of the major problems is that you guys are trying to just look at it, maybe try to visualize something, and then you try to go to the answer, and that's really tough to do. If I'm looking at this, I'm going to say the parent function is natural log of x, and all logarithm graphs before transformations look like this. Whether it's log base e of x, log base 2 of x, log base 5 of x, they're all going to basically look like this. I'm going to think about this transformation is going to flip it over the y-axis. So that would make them look like this. And then this 2, remember you might want to move them like this. Adding 2 to x normally makes it go left 2, but if you're reflecting over the y-axis, it actually makes it go right 2. So this guy was hitting -1, so if it goes right 2, he should look like this. And so how that helps me, obviously I'm not being super detailed here, but how that helps me is the asymptote equation was at x equals 0, flip it over the y-axis, it's still, x equals 0. Flip it over the y-axis, it's still at x equals 0. And then if I shift it right 2, Now he's at x equals 2. So that was one of the answers. And as you give yourself a sketch, it makes the domain a million times easier. It approaches negative infinity on the left, and it approaches 2 on the right. So that would be my recommendation. Hard to just look at that equation and know what's going on there without trying to give yourself a visual. Just to kind of give you guys a different perspective on this question. Not that you have to think of it this way, but I think it will maybe tie into some other stuff, whether you got this question right or not. What happens if I'm just looking at this equation? What happens if I try to plug in a number like, I don't know, 3? What's the natural log of 2 minus 3? Okay, why is it not possible? Right, you can't take the log of a negative number. We have to know that for other stuff. What happens if I try to plug in 2? If I plug in 2 here, this becomes 0. What's the natural log of 0? Not possible. You can't take the log of a negative. You can't take the log of 0. But then, as soon as you get anything smaller than 2, like 1, you get the natural log of 1, which whatever, that happens to simplify nicely. But there's like this wall. When x is 2 or bigger, it's not possible because you're taking the log of 0 or the log of a negative. But as long as you're taking the x value is less than 2, then it's fine. And that's what this visual is basically saying. As long as x is less than 2, it exists. If x is equal to 2 or bigger than 2, it does not exist. And that's really what domain is about. Domain's asking what values make sense to plug in. Okay, that may be more than you wanted there, but I think that's a good tie-in to the solving equations and stuff. Not many people have asked about question 8 today, but I really like that question. The human memory model, that's a real thing that there is quite a bit of studies on. I know that equation's overly simplified, but when you guys take it, like when y'all take a test on something, usually you're going to do your best like right away because it's fresh in your head. You've been thinking about it for weeks, but then 3 months later you forget some of it. 3 years later you forget a bunch of it. 30 years later you're glad if you remember any of it. But I think they say you usually remember like 40% of stuff after 1 year. And y'all are still young, so you don't really realize this yet, but as you get older, like things that happen in your life, like the details of stuff, like you remember less and less details as time goes on. You just remember like 1 or 2 things about things. So you have that to look forward to. But that is the human memory model, which is a logarithmic equation. Because at some point there's some stuff that you're just not gonna forget, so it like levels out. If you think about what a logarithmic graph looks like, at some point there's some things that just stick with you that you just never forget, no matter how old you get. Like factoring and solving quadratics. Okay, one more try. Anything else from 3-2? Okay, then let me remind you of the priority I would put on these. I'd put highest priority on your quizzes. Anything that you missed on a quiz, or even if you got lucky, because there was a couple multiple choice, those would be my top priority to study if I was you, because those are almost guaranteed to be on the test. And then my next priority would be the test review. If you feel good with those two things, then you shouldn't feel caught off guard by the test at all. And obviously everyone's a little bit different, and I don't usually have this perspective to give to you guys, but I did have 2 students in my B-Day classes that had to take it early, or they wanted to take it early because they're going to be absent next week when their classes are taking it. And one of the students made 100 on one of these 3 quizzes, but did not on the other 2, and she made 100 on the test. Another student made 100 on a different quiz, but not the other 2, and then still made 100 on the test. So the test is very doable, but they're also the type that they certainly looked over that stuff. So if you make sure you're comfortable with the questions from the quiz and the test review, you should not feel surprised. So
So test review, do these ones.
at least questions 1 through 9 and 11, yes. But you should have had those done last class. Okay, if y'all find something else, then please let me know. But if you've not made some sort of reminder about your test on Monday, now would probably be a good chance, or you're going to forget about it, and you may want to put an alarm in your phone about us being in room 1105 on Wednesday. Yes. Yeah.
Do you remember what numbers the test round with the quizzes were? I know that the last one was like 3.2 and a half. Was it like
Do you still have this? Do you still have this bookmarked on your Chromebook?
Yeah.
Yeah. I did also add these. Not that this is really that important, but for the class recordings, I've started putting them on our class website. Oh, y'all need pre-cal. In a calendar, just because I think that might be easier for people to use. You can just click the period. And then also the agenda slides. And now if you pull it up on your phone, it probably doesn't work well, but if you do it on a Chromebook, you can cycle through them, or you can click on it and make it bigger. But the numbers are always on the agenda slides. Okay, if y'all find something else, then please let me know so I can help. But if you're not ready to take your test, then please make sure you use this time.